Hello, Algebra 1B. This video is to go with the lesson on factoring quadratics, part 1. To kind of get you in the mindset of like what factoring quadratics means, I've got a quick review question. If you're looking at this and you're like, I remember this, like, let me go for it, you can go ahead and pause the video. If you're looking at it and saying to yourself, it's been a while since I've done one of those, you can kind of follow along with me. But looking at this problem, we had looked at this when we talked about how to multiply polynomials. So when we had looked at problems like these in the past, we said it's really similar to distributing. You just have to distribute twice. So looking at this, I would want to start by distributing this term here, our x, and multiplying x times x and x times 3. And then as our second step, we would want to distribute, my hand erased that minus sign. We want to distribute that minus 2 the same way. So multiplying the minus 2 times x and that minus 2 times 3. When we do that, the x times x would give us x squared. X times the 3 would give us plus 3x. And then the minus 2 times x, minus 2x. And minus 2 times 3 would be minus 6. Looking at this, maybe you're saying at home, but wait, like you're going to do that last step, right? It's not completely finished. Oh, that's my cat's tail. There's still one last part, which is combining your like terms. Notice that both of these have the same variable and the same exponent, that one that's hiding right there. That means we can go ahead and combine them. So our final answer would be x squared. The 3 minus 2 gives us 1, so we could just write plus x and then minus 6. So that right there would be our final answer. At this point in algebra, we know how to take something like this and multiply it out. We know how to distribute it. So we can go from this problem here to this expression right here. What we're learning in these notes is how to go the opposite direction. Which would mean going from something like this back up to a problem like this. What factoring is rewriting something to look like a multiplication problem. In the previous lesson, you were doing that using greatest common factor. So you were pulling out one common thing and then changing it into a problem where you had one term outside parentheses to multiply by. Another way you can factor is changing something to look like this. So what I just want to point out is notice there are two sets of parentheses. We've got x's and then numbers there. That's what the focus is on in this lesson. Sometimes we want it to look like this. Sometimes we want it to look like this. We want to be able to go both ways. Keeping all of that in mind, I will go ahead and write an example. I do not have the posted notes in front of me, so I'm not sure what the examples are in there, but the more examples, the better, right? So let's go ahead and look at how you would factor. Let's do y squared minus 9y plus 14. I like that as our example. And let me switch to a darker color. One of the first things you're going to want to do when you go to factor now is, now that you've seen both ways, anytime the expression looks like this, where you've got like a variable squared, a variable, and then a number, this is a good sign that you're going to be factoring into two parentheses. We call this a quadratic. What a quadratic is anything in this form here, where you've got, I'm going to write it, x squared plus ex plus c. So you've got your variable squared, you've got a variable here, and then you've got a number where b, c, and sometimes there could be a number here. So a, b, and c are all numbers, and then the x squared and x are variables. This is how we write the quadratic form. So anything that looks like this is a quadratic. That's going to mean that anything that looks like that is going to factor into two parentheses. So that'll be my first step, is just writing down those two parentheses there. Now, based on that practice problem we looked at the beginning, we know that these first two terms here are going to have to multiply to give us y squared, and that could be y times y. We know when we multiply y times y, it'll give us the y squared. Now, we also know from that practice problem at the beginning is there's going to be two numbers right here. Do you know what we know about those two numbers? Well, we know those two numbers should multiply and give us 14. So in order to help us figure out those numbers, what we normally do in class is we start writing down a list of any pairs of numbers that can multiply to give you 14. Put my list over here. There's the one that's so easy, sometimes people forget it, the 1 times 14. That can give you 14. And then there's one other pair of numbers, 2 times 7. That could give you 14. Now there's only going to be one correct pair of numbers that will give you all of this here. And the way you decide which pair of numbers to use is you use the pair that could combine to give you this middle number. So you pick the pair of numbers that can combine to give you a 9. In that case, a 1 and a 14, if you add them, it gives you 15. If you subtract them, it gives you 13. That's not going to give us a 9. But the 2 and the 7, if you were to add those together, it could give you a 9. So I'm going to use the numbers 2 and 7. Now the last part to this is we need some signs here. Now maybe when I wrote down that 2 and the 7, you said, well, wait, Samantha, that equals 9, not negative 9. You would be absolutely correct. So using kind of like what you know about negatives, about integers, what signs would we need here so that these two numbers multiply to give you a positive 14 and so that they combine to give you a negative 9? Do we need them both to be positive, both be negative, one positive, one negative? What combination is going to make that happen? Well, sometimes you just have to play around with it a little bit. So I've had some students say, okay, well, if I put plus signs here, that would multiply to give me a positive 14, but plus 2 plus 7 doesn't give me a negative 9. Maybe we could change like one of them to be negative. Well, negative 2 plus 7, that's still not going to give me negative 9. So sometimes it takes a bit of playing around with your signs, especially kind of depending on how confident you are with your negatives. But eventually we should settle on this one right here. A negative 2 and a negative 7 combined together would give you negative 9. And then negative 2 times negative 7 is going to give you that positive 14. Now the last part of this, you know me, I love to check. So what we're saying in this problem is we're saying this equals this. They both say the same thing. I've just written them in different ways. So an easy way to check would be, let's multiply this out and make sure it gives me what we started with. So I'm going to switch colors to red for our check. If I were to multiply this out, we could say y times y gives us y squared. Y times the negative 7 gives us negative 7y. Negative 2 times y, negative 2y, negative 2 times negative 7, plus 14. And then our last step would be to combine these two. Kind of goes back to why we're looking for a pair of numbers that can combine to give you negative 9, is because in this step right here, they're going to combine together to give you negative 9y. And that helps us know that our answer is correct. Now I've got like a lot of math written down here. There is only, this is my dog. There is only one line that's your final answer. If you're asked to factor this, do you know which line it is? It is this right here. Remember we said factoring is changing something to look like multiplication? This is what it looks like when you factor something. The rest of this is just us checking our answer. So it's always good to do. You know, I love checking, but it's not your final answer by any means. Notice this is the same thing as the question. So this is an example of factoring a quadratic. I'm going to erase this. I think I'll put another one up. If you're feeling okay and you want to try it on your own, you could press pause. I suggest at least try and see how far you can get, especially because these you're able to check all these problems. So it gives you a good idea if you've got the right answer or not. So let's look at, let's do x squared plus 18. There you go. So you want to pause the video now, try it on your own. All right, and you're back. Maybe you've tried it, maybe you think you know the answer, maybe you paused this and then realized you had no clue what you're doing. All of those are okay, but we're gonna do it now. Hopefully the first thing you did, or one of the first things you did, is because it's a quadratic, we've got x squared, x, and a number. That tells us we're gonna have two sets of parentheses. Another quick thing you can do at the beginning is because we know these first two terms here are going to multiply to give us the x squared, I can go ahead and I can fill in x and x. The rest of this is just going to be figuring out what these numbers are. Ask yourself, what do you know about those two numbers? There should be two things you say. One thing we know about these numbers is we know that they multiply to give you 18. And then the other thing we know about those numbers is they should combine to give you this 9 here. Depending on how great your math facts are, some people just like can figure out what that combination is in their head. Given enough practice, that can be you too. But if that's not where you're at yet, which is totally understandable, I would start off by writing factors of 18. So give yourself a little list of all the different numbers that can multiply to 18. And then as you're making that list, keep in mind you're trying to find the pair that combines to 9. So we could say 1 times 18. We could say 2 times 9. I like kind of keeping them in order, so notice 1, 2, 3, 3 times 6. 4 would be next, but 4 doesn't go into 18. Then 5, but 5 doesn't go into 18. And then 6 is already on our list. So that's how you kind of help keep your list organized. Got 3 pairs of numbers. Do you know which one we're going to go with? Well, we're going to go with this one here. Now, why on earth would I pick that one? Well, that's the pair that multiplies to 18 and also combines to 9. So the last step, it doesn't matter the order you put those. You could put 3 here, you could put 3 here, but we can fill in the 3 and 6. And all that's left to do would be to find the signs. We want a pair of signs so that these numbers combine to a positive 9. So when everything's positive, that makes it a little easier. It's just going to be two positives. So plus 3 plus 6 gives you positive 9. And a positive 3 times a positive 6 would give us 18. Now, obviously, at home you would be checking this, so we can... Hi, you came to learn algebra? This is Amaya. Obviously, at home you would be checking this, so we could say x times x is x squared, x times 6 is 6x, 3 times x is 3x, and then 3 times 6 is 18. That would leave us with 6x plus 3x is 9x plus 18, which matches what we started with. So we know we factored it correctly. I'm going to end this with like one last problem for you guys to try. Let's look at, let's do a squared minus 2a minus 35. If you have not tried one yet before seeing the answer, please make this the one you try on your own first. Go ahead, pause this, try it, and then come back to see the answer. And you're back. So looking at this, first thing we could do, it's a quadratic, so I know it's going to be in 2 parentheses. I also know we need to start with a times a to get our a squared. And then I would probably be looking at this 35 and thinking what pairs of numbers multiply to give you 35. When you go to write your list, you're going to realize it's a short one. 1 times 35 gives you 35. 2 doesn't go in, 3 doesn't go in, 4 doesn't go in, and then 5 times 7 gives you 35. We are looking for a pair of numbers that can combine to give you the -2 and that multiply to give you the -35. Now looking at this, did you figure out which one we want to use? We're going to want to use the 5 times 7. The The reason I keep using that word that combine to give you -2 is because they can combine with addition or subtraction. So the first two were examples of where they combined using addition. This one here we would need subtraction. We would need to subtract 5 and 7 to get our -2. I can go ahead and I can put my 5 and my 7 in there. Again, remember, it doesn't matter the order. You can do 7 and 5, 5 and 7. And the last part's going to be the signs. If you ever get stuck on the signs, that's usually what I see students struggle with the most. At the end of the day, there are only 4 options. Those two numbers can both be positive. They can both, that's not matching with what mine's saying. They can both be negative. You can have a positive and a negative, or a negative and a positive. So if you're just really stuck figuring out what signs are going to work, there's only 4 options. And if you need to, you can always write down all 4 to figure out which one is going to combine to give you the -2. Well, the only one that's going to work is this one here. A positive 5 minus 7 is going to give you that -2. So that tells me this should be a plus sign. This should be a minus sign. And I'm going to skip the checking part. I'm here to tell you that it's correct. If you have any questions on how to factor quadratics, please let us know. We've also got those Zoom classroom meetings that we've been doing. I also started doing one-on-one tutoring. So lots of different places where you can reach out and we can kind of talk through these problems. Factoring quadratics is going to be something that we're doing a lot in the upcoming lessons. This is part 1 of factoring quadratics. So there's going to be a part 2 and a part 3. So it's something that we're going to be using often. That said, so if you're struggling a little bit at home, please reach out to us. We really, really miss seeing your faces and hearing your voices, and obviously we're here to help. Thank you so much for watching this video. I hope to see you in another future one or in Zoom. So, yep, have a nice night. Bye.